here we're going to look at some cubes for the structural metals. So the main one, of course, is iron. Here we are. Cubic centimetre of iron. Stuff rusts. It's pretty cheap. What does it weigh? 8 grams. So roughly 8 grams per cubic centimetre. So we know how strong these things are. So iron's pretty strong. Actually, it's the gold standard. But yeah, it's pretty dense. Next up, titanium. Right, so titanium, not as strong and stiff as steel in general, but hell of a lot lighter. So there we are, 4.49. So what did we say with iron? It was 8, 4.49. So a bit over half the weight. Right. After that, what do we got? We've got, oh, this is an expensive one, but scandium. So scandium is even more expensive than titanium. It's actually quite an expensive light metal there. So it's 2.96 grams per cubic centimetre. And it's a bit, well, it's not as strong as titanium, but yeah, the weight's way down. The next one though is magnesium. So we've dealt with this one before. We've had a look in a previous video where we compared the weight of the magnesium against the rhenium that I also received quite recently. But this magnesium cube weighs 1.77 grams. The problem with this stuff is though, despite it being incredibly lightweight, it's very weak, has very little strength to it whatsoever. The other one that I haven't put there that really I should have from a while back, let me just pick it out now, is, here it is, what is it? Well, yeah, aluminium, obviously. Can't believe I didn't pull it out before. Anyway, here it is. Aluminium is, so 2.5 grams. So 2.5 grams versus the scandium that was, yeah, a bit more, and the magnesium, so 2.5, magnesium down to 1.77. So aluminium is actually a pretty decent structural metal. It has this nice, low weight, reasonable strength. It's great for aeroplanes. It's not as expensive as say titanium. Titanium would be the better choice for strength to weight in, weight critical applications like road bikes, bicycles compared to the aluminium. That said, now fiber composites are much better than titanium as well. So, but this was pretty much the best in terms of lightweight, strong metals. There is one champion though that we haven't pulled out yet, and that is, oh my goodness, beryllium. So there we are, atomic number of 4, so it goes hydrogen, helium, so both ridiculously light gases. Lithium, ridiculously light metal, but goes up in fire if you put it in water. Beryllium. So beryllium, you'll also see that it doesn't rust readily, and it weighs bugger all there, 1.75, so it's about the same as the magnesium. However, the beryllium is way stiffer, way stiffer, and much stronger. So it's actually stiffer than steel, which means it's stiffer than pretty much all of the others, but man, is it expensive. So the Chinese market, I just had a look, it's about $1,000 for 1 kilo of the stuff. Hell of a lot more if you buy them in 1 centimetre cubes, but I digress. The equivalent price is, a couple of order magnitude less for the titanium. So this one here, beryllium, you'll very rarely find in any structural applications other than the arms of the James Webb Telescope, where they don't want the thing to move very much and it needs to be very lightweight. So beryllium's what they ended up using for that. Also, beryllium lets X-rays through with no problem whatsoever. So, it makes a nice window on X-ray devices. And what else? Yeah, it's a neutron moderator as well. There's a whole bunch of nuclear applications I'm not necessarily familiar with. But anyway, there we are. That's all of the nice structural metals with an emphasis on this super duper light one, beryllium. Yeah, I could mention the fact that it's poisonous and all, but we've all heard about the berylliosis, which is this disease that you can get if you inhale a lungful of dust to the stuff, but it's not dust right here. It's a very solid cube. It's not going to react with my fingers or anything like that, so perfectly safe. Thank you very much. Good night.